Alright, so in this question, David can row 5 meters per second in still water, and it does say that he rows from the south, straight from the south bank at a 90-degree angle to the bank. So he's rowing this way at 5 meters per second. And if we think of that in terms of a vector, we could write it this way, across 0 and up 5, for example. And then we've also got the river is flowing east at 3 meters per second. All right, so that could be, so that's across 3 and up 0. And then there's also a wind from this is where I struggle, northeast. So northeast is over here, so there's a wind blowing that way at 45 degrees to the horizontal, of course, because that's northeast exactly. And that is at 4. So if I draw it like this, so that's at 4 meters per second. So this is the only tricky one. So if you think about it, we need the vertical and the horizontal values there. We do know that's 45, 45. So we know that these two sides, let's say x are going to be the same. So we've got x squared plus x. If we use Pythag, basically we've got 2x squared has to equal 4 squared. So x squared is going to equal 8. So x is going to equal 2 root 2, the square root of 8. So if you think about it, we've got 2 root 2 going down and 2 root 2 going across. So that vector would be minus 2 root 2 for the across and minus 2 root 2 because it's going down. So there that's all the activity happening. So if we talk about the actual boat, what direction this boat is going in, so let's have a look. The velocity vector, or let's say the boat is vector v for its velocity. So if we put all those together, so we've got the up one, and then we've got the across, and then we've got the down. So you know it's heading somewhere up that way is where it's heading. So we just put all those together. So in the horizontal component, I'll look at all the horizontal numbers. So I've got 0. I've got a 3 minus a 2 root 2. So 3 minus a 2 root 2 in the horizontal direction. And then I'll look at the vertical. So I've got a 5, a 0, and a minus 2 root 2. So I've got a 5 and a minus 2 root 2 in the vertical. My eyes always look weird. All right, that's the horizontal. So if that's the case, if that's the velocity vector for this this boat, then what we can do is have a look at the actual velocity it's going in. It ends up going with all those other forces acting on it, and the angle that it's going in. So if we think about it, so 3 minus 2 root 2 across, I'm going to put that 3 minus 2 root 2 across, and it's going up 5 minus 2 root 2, they're both positive. So this is the direction it's going, if I put a little angle there. So if I was interested in the angle, you can see I could use, this will be 90 degrees of course, so I could use tan theta is their old, again I've stuffed up, old age, and then do the inverse tan of that. Now when I do that, I think I get 85.48, something like that, degrees. But remember, if we want to find, it says the bearing on which the boat is travelling, and it does say to the 10th degree, so I'm looking for, if I look at a bearing, remember our bearings go like this, so I'll just do 90 minus that, and I'll say, alright, so the boat is heading, so it would be 90 minus 85.42, so it's 4.5 degrees. Or you could say north, 4.5 degrees east. But yeah, so that's its bearing. And then if we want the actual velocity, we'll just find it using Pythag. But what are we doing? So using Pythag, I want the distance. So this is my vector v. So I want the distance squared is equal to 5 minus 2 root 2 squared plus 3 minus 2 root 2 squared. So I'll get that answer and then I'll square root to find this, which is 2.17, something like that. So the speed of the boat, it's going at approximately, it did say to 2 sig figs, so 2.2 meters per second. Yeah, so if you just set it up and have a look at, you're putting all those vectors together, you should get your answer there.